Okay, so like I said last time, we're entering the second half of this course, which is going to be focused on data structures and algorithms and algorithm analysis. And the first data structure that we're going to be looking at are lists and list-based data structures. And the motivation is, as you've already seen, lists suck, arrays suck. That lists, sets, and maps are way better than simple arrays because they offer these they dynamically grow or shrink as needed. Throughout this process, as we're designing our own list, right, then we're going to exemplify and call out the object-oriented programming principles of encapsulation, abstraction, inheritance, and polymorphism. So it's a reinforcement of object-oriented programming at the same time. Of course, in real life, you would never actually roll your own, right? You would never actually create your own list data structure. You would use what is part of the language or part of a library to do that work, right? But we still need to understand why or how they work in order to understand when we should apply one type of a list versus a different type of a list. So to motivate this, again, arrays are bad. Once they're created, their size is fixed and they cannot be changed, right? Once I've created an array of size 10, then that means that it will only ever be able to hold 10 elements. If I want it to hold 15 elements, then I can't. If I only want it to hold 5 elements, then basically half of that memory is wasted. Not only that, but we've got a lot of bookkeeping to do on our own, right? How do we keep track of which one of those array elements are being used and which ones are not, right? If we've got 10 elements and then we delete the one in the middle, right, then there's a gap, right? We have to basically take care of that, and all that involves bookkeeping. Deleting elements means that we have to fill in that gap somehow. And the solution is to design and implement our own dynamic list data structure. What we're going to want out of this is that it automatically resizes, that is, grows or shrinks, as we insert, add, or delete elements. And we don't want to have to worry about those details. That's abstraction and encapsulation together. As you've been using an array list, a Java array list, you haven't had to worry about, well, how does it work? As you've been using local date, right? You didn't have to worry about how does it represent things. Does it use 3 numbers or 1 number or a string, right? We don't have to worry about those details. But now we do, because we're actually going to implement it. Then we're also going to want basic CRUD. Create, retrieve, update, and destroy. Now we've already done this with respect to tables, but these are the 4 basic operations on any data structure or any data. You need a way to put stuff in, you need a way to take stuff out, you need a way to update stuff, you need a way to delete stuff or remove stuff permanently, right? And so we're going to want to design our list with all of these things in mind. All of the details should be encapsulated inside the data structure. We should not have what are called leaky abstractions, where we leak information about how the list is being stored inside of the class, right? And we only want to use the data structure abstractly, right? We don't want to worry about the details of how it grows, how it shrinks, right? How it gets things done, okay? We're going to start with an array-based list, and I'm going to go through this process. It's an iterative process. But what we're going to do is we are going to, cancel that. All right, what we're going to do is we're going to design the interface, meaning that we are going to decide what are the public methods that should be part of this list. And we're pretty much going to take inspiration from a pre-existing array list, right? We're going to design the tests next. This is kind of like test-driven development, except that usually in test-driven development, you write the tests and then you implement whatever you're doing, right? We're going to kind of do that, but we're actually going to go back and forth because this is not a linear, one-way street. This is not a linear process. Sometimes when we write the tests, we're going to realize, oh, there was a design flaw, and we're going to have to go back to the design. Once we implement the interface, we're going to decide, I didn't think of a corner case. I'm going to have to go back and write a new test for this, right? So we're going to go back and forth on these 3 things, where we design the interface, design the tests, implement the interface, and then update. Right? We're going to go back to the design. We're going to go back to the test. We're going to go back and forth to the implementation until everything is perfect, right? So it's not a step-by-step process, 1, 2, 3, and we're done. It is 1, 2, we realized a mistake, go back to 1. All right, 1, 2, 3, we realized a mistake, go back to 1. right? 1, 2, 3, go, oh, we realized a mistake, go back to 2, right? Until we're done with everything, right? I'm probably going to want a demo class here to just to test things out, ad hoc in an ad hoc manner. So let me go ahead and give myself a demo class there. But otherwise, what I'm going to want to do is to create a class, and I'll call it integer array list. All right, I'm going to make it so that it just holds integers for now, and then we will understand that that's very, very limiting, right? And so we'll go back and we'll parameterize it so that, polymorphism, so that we don't have just an integer array list, we have any type of array list, okay? All right, my first thing is going to be to decide what the state should be. Implement the state. That is the member variables. Right? That's going to be my to-do. I'll come back to that because what I said was we want to design the interface, the public methods first. Again, going back to CRUD, I want a way to create things in order to insert things. So let me start with public void add element, integer x. Now what does this do? This adds the given element x, code x, to this list, except that how, all right? So let me come over here and let me go ahead and whiteboard this. What should the behavior be? If we had a list with 10, 20, and 30 in it already, and suppose that we wanted to add 42, what should the resulting list look like? Should 42 go in some random location, like right there? No, I don't like that either. Randomness is not good. Right? Should it always go first? We could do that. But if I'm just going to add it, where would you expect it to be added? At the end. Right? So we end up adding it at the end, and it results in 10, 20, 30, and 42. Okay. So let's put that into our documentation. Adds the given element to the end of this list. There, done. We're not done, but obviously, but I will leave it to do here to remind ourselves, implement this. Right? Okay? But we're not in the implementation phase yet here. We're still deciding on our design. What are we going to put in as our publicly facing methods? That's one way of creating things, one way of adding things. What's another way of adding things? I mean, it's just limiting. If that's the only way that I could do it, I could only ever insert something at the end, right? That's pretty limiting. That's not very flexible. So public void add element, integer x, add a location. How would I end up doing that? Int index, right? All right, and document adds the given element, codize it, x, at the given index. Right, there we go. Nice. By the way, what object-oriented programming principle allows me to have two methods with the same name, add element and add element, but with different parameters so that you understand that one of them is adding it to the end, and I didn't have to explicitly say add element to end, right? I didn't have to do that. I could just say add element, right? Which is much better. It is a form of polymorphism. It is method overloading, exactly. Right? And also make sure that you are putting it to do. Remind yourself to actually do this. Right? All right, that's good on the CRUD, on the C front for CRUD. What about retrieve? Get, yeah. So public void get element. Which element do you want? I could say get element first, the first element. I could say last. But we've already realized that, wait a second, index-based stuff is a whole lot better because I could implement those other two things, but I could always do it in terms of an index-based version of this. Right? So retrieves and returns the element at the given index. There we go. All right. I like that. Let's move on to update. So public void update element. We could do that. Basically, I'm going to be swapping it. If it was 10 before and I want to put 42, 10 gets kicked out and 42 takes its place. What's another word for that? Replace element? Okay, I like that. Right. And we're going to have to take that element x, and we will place it at a particular index. Right. So again, document this. Replaces the element at the given element, the given index code with x. All right, that's good enough for now. Right. Maybe we have some refinements to that design later on. Right. You might see immediately that that's not very useful because the return type there is void. How could we exploit that? How could we use that return type there? Right. That's update. What about destroy? Delete, remove elements. So public void remove element at int index. Again, an index-based version of this. So removes the element at the given index. There we go. All right, there's my public interface. Right. Now, before I start implementing this thing, let's do a little bit of test-driven development, and let's come over here and immediately start thinking about what tests we would want to run. So list tests. Tests. And by the way, I've always said that you shouldn't pluralize your classes. That's a guideline. That's not a rule. The one time I would do that, and in fact it's normal to do that, is with testing classes, because those testing classes never make it out to production, right? You don't have any production classes that are pluralized. And it's just a collection of tests. So if you called it list test, right? Test suite, maybe, that'd be a lot better, I think. But it's usual to call them list tests, okay? All right, remember that you use the annotation test, right? And public void test 01. We'll come back and name this a little bit better. But my integer array list, right? And I'll just call it list is equal to new integer array list. All right, how are we going to test this? Obviously, I'm going to want to test everything eventually. But one thing I want to test is adding something. Let's just go ahead and add 10. All right. Now, how do I know that that test passes? Oops. All right, so if we want JUnit, what do? Right click. Where is it? Build path, add libraries, and JUnit, there we go, and 6, yeah, sure. What the hell? There we go, and now I can import Jupyter test, there we go. All right, how am I going to test that 10 actually got in there? So did 10 actually make it into the list? Right. Well, I'm going to have to retrieve it. Int expected is equal to 10, and int actual is equal to list dot get element at what index would you expect it? 0. Right? And then assert that expected is equal to actual. And why are you complaining? Oops, I didn't have a return type there. There we go, int. Integer, I should have. There we go. Now my tests are okay. All right. All right, so if I were to run this right now, well, it's not compiling. Let me go ahead and return, or to-do implement, right? To-do implement. And for now, just to get it to compile, I'll return null. Is null going to be equal to 10? No. So the test fails. All right. That's one test. How would you extend that test? In fact, I should probably rename this to a test add one element. Add and retrieve one element. Right? Really, really long name, but so what? It's testing. Right? What else could you test along these lines? Oh, okay. We'll come back to that later because we haven't even done implementations yet. But test add and retrieve multiple elements. There we go. So did 10, 20, and 30 actually make it into the list? You could test for duplicates, right? So there's the first one. The second one would be 20. And so I would want to retrieve the one at index 1 and assert that those are equal. And then 30 and the index 2. Now obviously this is going to still fail, but now I've got 2 tests that fail. Okay? All right, that's good testing for now. Let's come back. Again, this is a continuous process where we go back and forth between each one of these 3 activities. All right. Now I'm going to actually have to implement something because I don't know if those tests actually work. Because they don't work because I haven't implemented anything yet. All right. How am I going to implement the state of an array list? As in the name, it says that there is an array under the hood that is storing these things. So int arr. Right? First of all, what should I be putting in the front there? What? Private. Why? Because over here, if I were to create that list is equal to new. There we go. List dot arr. I could change that. Right? 1 is equal to 42 now. Right? That breaks encapsulation, and it leaks abstractions. Right? I'm ripping open the guts, seeing, oh, there's an array under the hood, right? I ripped out that engine, do something with it, and then put it back. That violates both encapsulation and abstraction. Right? So let's make it private so you can't do that anymore. Instead, you are forced to work through the publicly available methods, the interface. List.add 10. Right? List.add. Actually, let me go into, I'll leave it for like that for now. Add 10, 20, 30, whatever you want to do. Okay? All right, that's how it stores stuff. Now let's go ahead and actually implement this thing. Let's see if 10 actually gets in there. So this dot array of something is equal to x. That's how I can put something into the array. Where do I put it though? I need to put it at the end, remember? At the end of the list. How do I know where the end of the list is? Well, first of all, is this even going to work? Did I ever initialize this array? Nope. So let's go back and let's create this is a very special kind of method that has no return type, has the same name. What is it called? A constructor. ARR is equal to new int and question mark, right? All right. Well, when I create an array in Java, I have to specify the size of that array. Let's just go ahead and make it of size 10. You can make it of size 1, but it only ever holds 1 value. This at least holds up to 10 values, right? Okay. Now will that work? Where do I put it? So don't think of that 10 as the size of the array. Think of it as a capacity, right? So move off that. So what I've got here is 0, 1, 2, ... up to 9. I've got an array that can hold 9 things. It doesn't actually hold 9 things right now, right? I haven't put anything into it. So what is the size of the list? Not the array. The size of the array is 10, right? What's the size of the list if I have not put anything into it yet? 0, right? So where are you going to put it? Well, at the end of the list, it's going to be right here, 42, right? That means you put it at index 0. What if there were already some things in there? 10, 20, and 30. There's index 3. Now how big is the list? 3. Where would you end up putting it at the end of the list? 42 right there, right? So it seems to me like I need to keep track of that thing right there. I need to keep track of the size of the list. Private int size. Okay. Initially, how big is the list? 0. So I'll set that to 0. And it's best practice to always use this, even if you don't need to. Okay. All right. Now where am I going to put x? This dot size, right? If it's of size 0, I'm putting it at the beginning. If it's of size 3, then I'm putting it at index 3. Because of 0 indexing, it's going to be at size.list. And by the way, I had 3 things in there before, 10, 20, and 30, and now I've put in 42. How big is the list now? 4. And so this dot size plus plus. Okay? And like I said, we're going to go back and forth between the interface, testing, implementation, and et cetera, et cetera. Now that I've got a size, maybe I should publish that to the world. Public int get size. Right? Returns the size of this list. Why would you ever want that? What if you needed to iterate over it? For int I equals 0, I is less than the size of the array, or the size of the list. Right? So returns the current size of this list. If you ever need to iterate over it with a traditional for loop. Okay? All right, now back over here. Does this work? Well, let's do some ad hoc testing. Right? I'm not going to add 10. I'm going to add a whole bunch of things. For int I equals 0. Let's go 10. I is less than equal to 100. I plus equals 10. So I'm starting at 10 and going up to 100 by increments of 10. So 10, 20, 30, 40, 50, all the way up to 100. List.add I. Okay? I don't have any way of testing this yet, except over here in the list tests. And I haven't implemented this get element yet. But I'd really like to test that to see if it works. Here's another way of doing ad hoc testing. Done. Let's go ahead and set a breakpoint. And let's use the tools that Eclipse gives us, or any IDE gives us. And let's go ahead and debug it up to that point. Right. Once we've debugged it, we can look at it. Here's my list. Right? It's of size 10. Did we insert 10 things in there? Yep. What do they look like? There's the array. 10, 20, 30, 40, all the way up to 100. Ad hoc testing looks like it works to me. Right? That's just a sanity check. That's not real testing, though. Right? Okay. All right. Let's test one more here. Right. What's going to happen now? Where we're inserting 11 things. 10 up to 110. Predict. Does our array have a capacity for 11 things? Nope. It's now going to fail with an index out of bounds exception, right? Where? In the add element right there, right? So now we need to go back to the drawing board and redesign the implementation here. We don't redesign the interface, but we would just redesign the implementation here. If it's full, right, it has a capacity of 10, there are 10 things in there, it's full. What do we need to do? We need to expand it. If the array is full, then we will expand the array. Okay? How do I know that the array is full? This.array.length, that tells me the capacity, right? What tells me the size of the list to say that, oh, it's full? This.size. So if that's equal to this.size, or better yet, since I put it into a getter, there we go. That means it's full. How do I expand the array? I can't, right? Once an array is created, its size is fixed, right? Now in C, you could do something like realloc and cross your fingers that it works, right? It'll, as long as that memory chunk directly after is free and big enough, it'll allow you to expand. Otherwise, it'll return null, right? I don't have that luxury over here. Instead, what I'll do is I'll create a new array. Int BRR, because that comes next, right? AB. New int. How big should it be now? This dot array dot length, right? That's how big it was before. Plus 10, plus 1, plus 10. You could go with plus 1, but that's kind of useless. I mean, you're only ever growing it once, right? Think of it as think of in the future when it has 1 million elements, and you need to add 1 million more elements. It only grows by 1 each and every single time. That's slow. So 100 is 10 is a little bit better. Maybe 100 is even better. Maybe 1024 is even better. Why 1024? That's a kilobyte, right? So 4096 bytes, right? Or you could even say double the size. So if it was 10 before, then it goes to 20, then 40, then 80, right? There are a whole bunch of different strategies that you could test out and see which one is the best. That's a different type of testing, right? That is efficiency testing or load testing, right? And then you would go and find, oh, well, it looks like it works best on memory and space and efficiency if we do this strategy, right? And then you'd go with that strategy, right? But for now, we'll just go ahead and expand it by a factor of 10, or not a factor of 10, but by an additive factor of 10. Right? All right, what's in that new array? What's in this new array right now? Nothing except for a bunch of zeros. So let's go ahead and copy over elements. For int I equals 0, I is less than this dot array dot length, I plus plus, BRR sub I is equal to ARR sub I. I've copied everything over. It still has 10 extra, capacity for 10 extra elements, but I'll leave those as zeros, right? And now I need to make sure that this data array is equal to BRR. Right? What happened to the old array, by the way? Yeah, I lost reference to it, and in Java, it's now eligible for garbage collection, and it'll take care of it for me. If this were C, I would do something like free this.arr and then change the pointer. But there is no, with automated garbage collection, it takes care of it for us. All right, now does it work? Well, no news is good news, but once again, I'm going to go ahead and use my debugger to see, did 110 get in there? And it did. And look, we've got 9 zeros after that. That means that it's got capacity for 9 more things. It looks like it worked to me. Okay? All right. So let's go back to our Java perspective here. That looks good for now, except that I really do not like 1, 2, 3, 4 lines of code. Why do in 4 lines of code what you could do in 1 line of code? This dot array is equal to arrays dot copy of ARR this dot array dot length plus 10. Right. So what that does is it will copy over ARR, deep copy, into this, right? But it will be now of size, whatever the size was before, plus 10, padded out with zeros. If you went with minus 10, by the way, it would shrink it, and then it would ignore the last 10 elements. But that takes care of it for us, and probably way more efficient, by the way. It's probably doing some mem CPY under the hood here, right? Yeah, system.array copy, and that, yep, it is a native. Native means that it is calling a C library function, and that C library function is probably mem CPY, right? So it's way more efficient now, right? All right, let's see what else next. Add element at a particular index. Okay. Let's outline this. Actually, no, before we do that one, let's do this one, get element. Because that's going to be really easy, or seemingly really easy. If you want a particular element at a particular index, what is it going to be? Return this dot array at that index. And you're done. I think we have enough to test run our JUnit tests over here now. Hey, they all pass, right? But once again, we're going to go back and forth on this stuff, right? For example, am I writing the debugger still? No, yep, I am. So let's stop that. There we go. All right, so I want to know, I don't know, int x is equal to list.get, not get size, but get element 100. Right? System.out.println x. What's going to happen here? Error. What kind of an error? Yep, an index out of bounds exception. Array index out of bounds exception. Do you see an array here at all? I see a list, right? This is leaking information to the outside world about how it is storing stuff. That's another leaky abstraction. Right? I want to make sure that that doesn't happen. So I'm going to write my own code to do bounds checking. If index is bad, then I will throw a new runtime exception. No such element at index plus index. There we go. I'm going to throw a different type of exception. Now, what does a bad index mean? All right, so this dot size, or oops, dot get size, if the index exceeds that, right? So if it's greater than index, is that right? There are 10 things in there. You asked for the 10th thing. Strictly less than? Less than or equal to. Because if there are 10 things in there, what should you be asking for? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. But when you get to 10, that's when it's bad. Is there another badness? Yep. So if index is less than 0 or it's greater than. Now over here, there we go. Now I'm getting a much more sensible message here. No such element at index 100. Right? How would we test that over here? Public void test out of bounds. All right. So let me go ahead and create a list. I'll put 3 things in it just to be different. Right? And at this point, let's look this up. JUnit assert throws. I forgot how to do it in the last class, and I just didn't look it up. It should be assert throws. What would it look like? Find assert throws. I don't need to capture it. I just need to look. Okay, so I was doing it almost correctly. So assert throws, runtime exception, and then I would do list dot get 100, get element. There we go. And then we need to bring that in. That's going to be static import right there. There we go. All right. So it should throw a runtime exception if we ask for something that doesn't exist. 3 out of 3, please. Yay, we got it. All right. Another test. That's for if it exceeds, right? Test out of bounds 0, 2, 0, 1. Right. Or you could be more descriptive, negative. Right. So -1. Right. Yay, 4 out of 4, right? What else should we test when it doesn't throw an exception, right? Test out of bounds valid, right? So there are 3 things in there. How do you do assert not throws JUnit? Right? Oh, by the way, what is this thing called right here? We've never covered this in Java before. It's a lambda function, right? It's basically an anonymous function. If I had had a method called my method, right, it would have a name, but it doesn't have a name. So it just has parentheses, right? And it doesn't take any arguments. It maps to, and then here's what actually gets executed with respect to that function. We will call list.getElement on -1, and then if that throws an exception that matches this runtime exception class, then it passes, right? But what I want here is how to test it. If no exception is thrown, does not throw. Assert does not throw. Throw or throws? Let's find out. Import, there we go. All right, and then what's a valid one? 0? Oh, come on, what's wrong with it? Add static? Come on, there we go. All right, why are you not? There it is, does not throw. Huh, line does not throw. Oh, If it doesn't throw it, can you check to see if it's the correct type? No. So there we go. There, is that valid? Hey, we got another test out of that. We're already up to 5 tests, and we've only done 1 or 2 functions so far. Right? Cool. Right? You could also say 1 and 2, because we've got 3 things in there. Right? That's a little bit more robust. Yay. At this point, what I'm going to do is I'm going to show you a tool here. Right? So you've got the debugging tool, you've got the running tool. Yeah, that's what I was pressing the entire time. And then you've got this other tool right here. It says it's coverage. Okay? Now let's go ahead and run this test suite with respect to coverage. Everything is green, right? So let's come over here to integer array list here. What it does is it says that test suite that you just wrote, anything that's green is actually tested. Of course, we created a list, and so that constructor got called. Green, it was tested at some point by at least 1 test. What was not tested? This red stuff, right? Now, this yellow stuff was tested, but it was false, and so line 24 was never actually tested, right? That means I need to go back and I need to create a test case that would trigger that, right? That I would do something like this, where I've got that none of that stuff is tested. So let's go ahead and create a test over here called at test public void test expands list. Right? There we go. And we'll do that. And let's go ahead and assert that the list.getSize is equal to, how big should it be if I insert 11 things? 11. Right? Let's run that and see now that we've got 6 out of 6 tests passing, right? And now let's come over here and let's run the coverage tool once more. And what we see over here is that that thing that was red is now green. It's actually been tested, right? So these are good color-coded, visual feedback of what has been tested and what has been not tested. Obviously, those haven't even been implemented yet, so they're not tested. But now getSize has been tested as well. Generally, your goal should be for 100% code coverage. That doesn't mean that that's sufficient. I only have 1 test for this thing right here. Right? That could be called multiple. Like the first time that it's called, it could actually run and be fine. But what about expanding it from 20 to 30 or from 30 to 40? Do those work or do those fail for some reason? Right? In which case, the code coverage by itself is not going to say, oh, it actually fails for some reason on the 5th iteration of this thing, right? That's why you need more testing. And testing only ever gives you an assurance. Like, yeah, I'm 99% sure that this is all this code is correct. It's not a proof, right? Like you have in 235, all right? I forget how to get rid of, just go ahead and hit the X buttons to get rid of all the color coding, right? And you're back, okay? All right. Now that's got me thinking. Oh, no, now let's do this one. All right, sorry. Add element. Let's outline this since we're not going to have time to do it. What's the very first thing I should do since this is now index-based? Check bounds on index. Good. 2. What if it's already full? Check capacity and expand if necessary. Because that's exactly what we did up here. Right? We didn't do any bounds checking on here, did we? No, because that doesn't make any sense. Right? There's no index there. 3. Now what do we do? Expanded it if necessary. Yeah, add x to index. How though? We need some details there. 3a. So let's go back to our whiteboarding here. Go away. 10, 20, 30, 40. And let's just go ahead and say it's like that. 42. Add 42 at index. Say 1. Where would you expect it to go if you added it at index 1? Indices 1, 0, 1, 2, and 3. Where should 42 go? After 10, so in other words, Do we want to lose 20? Nope. We want to take everything here and move it in order to get room for this. So we'll expand it out, well, not expand it, but we'll shift everything down so we can make room for 42 right there. All right? So we're going to have to shift stuff. Shift things down from index to the end to make room for x. Right? Then 4. Now it's add x at index. Right? Actually, that's 3b maybe. Right? Step 4. There's one more step. We added that at the end. Then what did we do? Increase size. Size. There we go. All right. Well, those two things are easy, right? This dot array of index is equal to x. Increase size, what's your that look like? Plus plus. All right. What about bounds checking on this? We're just going back and filling in the gaps now. Right? We have enough time to at least do the easy stuff. If index is bad, right, we will throw a new runtime exception of cannot insert at index plus for list of size plus this dot size. Let's just go like that. Plus. All right. How do I know that the index is bad? Let's come over here and again whiteboard this stuff. All right. So let's go ahead and get rid of all that. I want to insert 42 at index -1. Is that good or bad? Bad. Index 0. Is that good or bad? Good. What is that doing? That's shifting everything down so that 42 ends up right here. So that's okay. I don't have green. I should have green. There's no, there, green. Check. There we go. All right. 1, 2, 3. Are all those okay? Yep. Because that would be here, here, or here, meaning that the last one, 40, would be shifted down so that 42 could be here. Right. What about 4 though? Oops. Yeah, why would 4 be okay? That's inserting at the end, right? Right. Good. 5? Bad. I agree. So let's come back over here. If index is less than 0 or index is strictly greater than this dot size, right? If it's equal to this dot size, 5, 0, 1, 2, 3, 4, 5, you're just inserting it at the end. Okay? All right. So all we need to do is check our capacity and expand if necessary. Guess what? Copy, paste. There we go. In fact, it seems kind of icky already. Look at this line. Look at these two lines right here. They're exactly the same as right here. Right? Don't repeat yourself. DRY. Right? Which one of these functions, which one of these methods is the more general method? Which one is more flexible, more usable? The second one. So the first one should be in terms of what? The second one, right? So this dot add element x, and where are we going to add it? Size, right? Cool. Now think about this in terms of code coverage, right? Do we really have to test this one? No. If we end up testing this one right here, we've all this is doing is it's calling another function. We just have to make sure that we're testing this. Now it will always appear in red here. So if you don't like that, then of course test it once. But ultimately, you'd ever only be testing this one down here, right? All right, so I will leave this as a to-do for Friday. All right. And I will be coming on Friday. Oh, what's wrong? I need a semicolon. There we go. By the way, if you want to, you can come out and run with us on Friday. Are you coming again? Okay. At 3:30. I forget what it is. I mean, the weather is getting fine enough that more people should come running with us, right? 2:45. 2:45 right out to the shore. We'll do a 5K, or actually Bonita is injured, so she can't run. So if we want to, we can do a 10K instead, or 14. All right. All right. See you on Friday, maybe.